my name is Abramson. I am a second-year mechanical engineering student at the University of Alberta. In this video today I will be discussing some of the similarities and differences in mechanical engineering throughout the past century. So to summarize, my first point will be some of the similarities in the past century between now and then my second point will be some of the minor differences, and my third point will be some of the major differences in mechanical engineering in general, which I think have really advanced society. So the first thing that hasn't changed for mechanical engineering is that safety is our first priority. We still strive to make the machines we design, the planes, the cars, the toys, all safe for the people operating them, as they would have 100 years ago. But some of the other things in mechanical engineering that are still similar are the fundamentals behind mechanical engineering. The thermodynamics courses, design courses, or vibration courses would all be relatively the same, because designing an old Ford Model T compared to a Ford F-150 would still have the same fundamentals behind it. Whether that's the vibrations in the crankshaft or the combustion of the gasoline in the engine. All these factors still have to be considered when designing a combustible engine, or whether it was 100 years ago or today. But obviously what has changed is how much more fuel efficient vehicles are today, and also how more luxurious they are. So this brings us into my next point on the differences in mechanical engineering. Engineering now compared to then is also very different, because we have all sorts of technologies, the internet, programmable calculators, and these all help with the mathematics behind designing, etc. Back in the old days, they didn't have mechanical engineers, or engineers in general. They didn't have calculators. They had these things called slides, which I have no idea how to use, but calculators are a huge advantage today. Also, another major thing that has changed, which I believe is a big thing, is the variety of metals available to us mechanical engineers, and the amount of finishes available, from the CNC machine or from the machinist. You can get fine to rough surfaces, whatever you need it for. Any application that you desire, you can get it. And there's all sorts of variations in carbon steel. There's thousands and thousands of different kinds of metals available to our use, and cheap too. Not cheap, well, I don't know the price, but yeah. And metals have advanced as well too, by meaning their ductile to brittle transition temperature. An example of this would be the Titanic. It would have, when it cracked and when it hit the iceberg, it would have cracked because it would have been in a brittle phase. But these metals have advanced and gotten the ductile to brittle transition temperature down. So if the metal on the Titanic was used with the metal today, it wouldn't have broke, because it would have been a ductile failure instead of a brittle failure, and you would have saved thousands of lives. This brings us into my last topic on some of the major differences in mechanical engineering which have hugely affected it. The software applications. That's the major difference, I think. AutoCAD, SolidWorks, these all help mechanical engineers visualize their models without actually making them. So it makes the design process way quicker. These softwares can actually do a lot, and they can do a lot more than just 3D modeling. They can show stress concentrations or do finite element analysis, whatever. They all help with the design and the production of today's society, and they help with mechanical engineering. And this is why projects are way quicker than they were a century ago. So with all these new advances in technologies, they really have accelerated engineering in general and the quality of life. So to summarize again, I talked a little bit about the similarities and briefly on some of the minor differences, and then briefly on the major differences. But it's just an introduction into some of the similarities and differences in mechanical engineering.